Okay, so you have seen the introduction to the soil moisture water balance model. So this model was written in Python, and it will use um, NetCDF file format for input and output. So in order to run the model, the first step is we need to prepare all the data set in the right format. So that's why now I will give you a presentation about how it is done. And in this presentation, uh, in the end of the presentation, I can also show you the notebook that we use to prepare the input for data. And in the afternoon or after this presentation, there will be one exercise that you will try, you will learn how to use Python to open, to read, and to analyze NetCDF file format. Um, I will also give you a quick introduction about that in this presentation. So okay, this presentation, first we will just to revise a bit uh, the geospatial data format and a short introduction about NetCDF and the step in data preparation. So geospatial data format. So as you know, uh, if you have worked with a raster file or shapefile, these are considered geospatial data, and there's some properties of these files, including resolution, which mean what is the size of the grid in space or the interval in time, and extend what is the coverage in space and what is the duration that the data cover. The range of values can be a true number or a real number, or it can be in integer. Depends on the physical variable that the data contain. Sometimes the data sets can also have a scale factor. This is to save storage space. So all of these information should be found in the metadata. So this is to stress the importance that when you use a geospatial data, either it's from remote sensing or model products, it's always important to look at the metadata of the datasets, um, and also how does this that do the data have is it time series format or spatial data, or is have both time and spatial dimensions. Uh, if it is time series data, most of the it will be fixed in space. So, for example, rainfall data that collected in a rain gauge station will be fixed in space with a coordinate and values in time. Meanwhile, a raster data that represent evapotranspiration of a month will be fixed in time, but the value will be variable in space. So these come to multi-dimensional data that have both the time dimension and the space dimension. Uh, and this kind of data sometimes also called data cube, which I will show you later. The data formats of geospatial data can be plain text or GeoTIFF or shapefile or NetCDFs, and the data usually follow the Open Geospatial Consortium standards. This is a standard for the international community, and it's freely distributed. Again, the key points when you look at the data is the metadata and georeference. So, and sometimes you need to check the time space consistency of the data sets. So, for example, how if you look at the time series, there's a seasonality match with what you know from the field. If you look at the if you look at the raster data, for example, precipitation, there's a variation of the data sets matched with the topographic effect or orographic effect, um, due to, for example, like where in the mountain do you see higher precipitation. So this is to check the consistency of um, each dimension. Um, so NetCDF is a network common data form abbreviation. This is one of the data format that follow Open Spatial Consortium standard, and it's very useful for sharing and access data. It's a multi-dimensional format. It's machine independent, which means it's can be used in any kind of operating system. And usually the NetCDF file uh, been sharing that have been shared by the community will be self-describing, which means it's contain all the information about the data sets, all the metadata that we have looked in the previous slide. And NetCDF file, the values in the file will be array oriented. So a in in the time dimension, it will be a vector of time index, and in space dimension be to the array, which is like a map. So a data cube will contain all of these information, all the values, and the time and space index. And this information will be in a complete description of the data. So this can be used to store not only remote sensing retrieval, but also can be field measurements or modeling data. And also in the NetCDF file, you can also store multiple variables. So uh, not only the global attributes like spatial reference, description, and in the dimensions uh, with latitude, longitude, and the time index, but also it can store multiple variables. For example, in one NetCDF file, you can have precipitation, evapotranspirations, and other variables. Um, and also the data then will be arranged in the time and space index. For example, here, if the data variable ET, you can access it with the index of latitude, longitude, and the time. And then you can get the actual value of that grid in the data layers, in the data variable. So with NetCDF file, you can easily open it in QGIS. So for example, here is a screenshot of uh, when you open it in NetCD in QGIS. You can use the inspect tool to check the time series of each pixel. Like here in this screenshot, I have the evapotranspiration NetCDF file and at monthly time scale. So when you click on one of the pixel, you will see the time series um, of monthly value in that pixel. And this NetCDF file has multiple bands, and each raster band is fixed in time, so it has one time index. Um, you can also use Xarray library in Python to work with NetCDF file. So the model that Solomon presented was written in Python, mainly based on the Xarray library. And after this presentation, you will have one exercise using Xarray library to open, to read, and to analyze a NetCDF file. So, for example, here in this animation, you can see with one line of code, you can get you can read the information of the, sorry, you can mm, you can read the information of the data. So see all the attributes, metadata of the data sets. You can also plot histogram and also see the mean value like in QGIS, the time series value in QGIS, and you can also quickly with just one line extract the monthly average and yearly average. This is an example of how you can use it, but during the exercise you will see you can have the hands-on experience using Python to do this. So before I continue with the step in data preparation for Water Accounting Plus, I want to ask if you have any questions so far. Okay, I take that as no. So I will continue. So the first step in data preparations, when you collect all the remote sensing data, and if you have any ground truth data or a specific land cover maps of the basin, as you remember in the lecture by Dr. Elga Salvadore in the first day, she have shown you what kind of land use categories that we have in Water Accounting Plus. So in order to categorize this, we have to derive these data layers from land cover classification with some ancillary maps. So this is to revise a bit about the 4 land use category. I will make a poll questions. The option for the poll question is on the screen. A is for protected land use, B is for utilized land use, C is for modified land use, D for managed water use. And I put the questions in the chat box. So the question is, which land use category does irrigated cropland belong to? Can you see the poll?
Yes, I see the poll.
Okay, I will give you a few more seconds to answer. So which land use category does irrigated cropland belong to? It's okay if you give the wrong answer because you just watched the lecture videos yesterday. This is just to revise a bit. So Serif and Ala, you have the answer? Or are you still thinking? Okay, I will stop the poll now. I have everyone have the right question, the right answer, which is D, managed water use. Why is it managed water use? Maybe Lauren, can you explain to everyone?
I will try my best. Because it's using additional water than just the rainfall. So A, B, and C are different ways that the precipitation interacts with the land, but then D is where we add additional water to that system from outside precipitation. Is that
Yeah.
kind of
Yes.
correct?
So for managed water use, the difference between managed water use and utilized land use is that managed water use modify both water flows and land use practice. So you convert a natural land into cropland, and you also modify the water flow in this particular area. For utilized land use, mostly people there's no land use practice or water flow modification, but it's not, but people utilize for different purpose, like a natural park that's not protected. Okay, maybe one more questions. Um, which, let me post the second question. Which land use category does rain-fed cropland belong to? And I will start a poll. You have to choose A, B, C, or D. So from the previous question, you might already get a hint for this. So A is protected land use, B is utilized land use, C is modified land use, and D managed water use. So rain-fed cropland, which means there's some modification in the land use practice. For example, you turn a bare land into in an agricultural area, you grow some crop there, but it's rain-fed, so which means there's no water flow modification. All right, so I think again, most people get the right answer, which is C, modified land use. I see some utilized land use also. So the main difference between utilized land use and modified land use is that once you modify the land surface, like for example, you change the type of vegetation, you change the type of uh, surface cover. For utilized land use, people still have access to it, but it's the land cover, the land surface is not modified. So that's the idea of these 4 types of land use. For those you don't have the right answer, it's okay. I think you can revise by go back to the lecture on the first day in this particular part. Okay, so I will continue. I think that's more or less clear for everyone. So for land use classification, this in more detail. Maybe you can read this later in the slides. But the idea is we will use some global data sets to classify protected land use and managed water use. For protected land use, we specifically choose the IUCN classification, categories 1 and categories 2, because these are strictly protected area. So sometime in national park, even though it's called a park, you might still have some modification of land cover. That's why we use these categories by the UNEP. This to consider only strictly protected area. For some time, these global database will not include some local information, like you have some wilderness area that is not classified in IUCN database. This means that you don't just blindly use the data sets from global database, but you also need to, in addition, use some expert knowledge of the basins. So this is what we did, but when you apply in your case, please keep in mind that there might be some area that is not from the global map. And also for managed water use, uh, we use a irrigated cropland and built up class in land cover classification maps, and also constructed reservoir from the global reservoir and dam database. So again, this global database might not always include all the reservoir, especially some new constructed, newly constructed reservoir in the basin that because the database I remember is from 2011 or something. So if there's some newly constructed reservoir, you also need to take this into account. So all the water bodies that not natural except natural lakes will be reclassified as managed water use class according to the reservoir. Um, and the rest, the modified land use will be crop land that is not irrigated. So all the rest area that is not protected, not managed water use, and not modified land use will be classified as utilized land use class. So you can read more detail later. So after that, after you prepare some extra layers, the next step is to create the NetCDF files from the geotypes, the raster data set that you collected, either from, in this case, in Vapo, but sometimes if you use other remote sensing products, it's also needed to create the NetCDF files to follow the same standards for the model. So for this, the required libraries in Python are Xarray and NetCDF4. If you have done the first exercise in module 1, you should already have the Python 3.7 environment, but you might not have Xarray and NetCDF4 yet, but I will show you how you can install this quickly. And the data sets required for the model that Solomon just have presented here are monthly precipitation, monthly actual evapotranspiration, and reference evapotranspiration, yearly land cover classification map, and the topsoil saturated water content, which is static. Okay, so I think I have 4 minutes left, maybe not enough to show the exercise. Maybe we can stay a bit longer. And if not enough time, we can continue during the afternoon. Okay, so for the exercise, uh, on the platform of Model 2, you will find the exercise in this link, exercise using NetCDF files in Python. If you click on this, you will find the zip file and the instructions. So first of all, you download the zip file and please unzip it to the same folder with day 1 exercise. So now here, for example, I have this folder, unzip. I can also put it in the same day 1 exercise folder. And then you start Anaconda prompt. I started from this window so you can see it. So the same steps like before, you can start change the directory. Right. And then activate the Python 3.7 environment called Vapo OCW that you should have from the previous Python course or from day 1 exercise. And then you can open Jupyter Notebook. Okay. So in day 2 exercise, there are 2 notebooks. There are 2 notebooks. One is data preparation, which is the scripts for the process that I just explained in the presentation. For this course, you don't need to run the script, but this is only for your reference. I can also show you this how it looks. So in this, also there one step for reclassify land cover classification into land use categories. and the source of ancillary data. I, for example, for the global database on protected area, you can download a country shapefile from this website. For this exercise, for the water accounting studies that we've done before, I already prepare a map for 17 countries in Africa and in Middle East. So just by combining all the shapefile from all the countries that I can find in this database. So this already covers at least 17 countries, I remember. And then there's the reservoir shapefile that's also provided to you all in the data. So the step is like, first you just run the script. If you run it for your own basin, you might need to change the output folder path and the input folder path for land cover classifications. But this script should be the same. Also, when you create the NetCDF files, you will need to, if you create it for your own case studies, not Upper Litani Basin, then you need to provide the metadata in this code cell. For example, the name of the basin and the path of the shapefile of the basin, the path of the folder path of input raster data, as well as the unit, everything. And then in this script, it will create the NetCDF files. So this is only for your reference later on if you want to apply it for different basin. So you need to run this to create the NetCDF files. And also, in order to run this script, you should have already collected all the raster data required. In this case, precipitation monthly, actual evapotranspiration and interception monthly, reference evapotranspiration, land cover classifications, and the topsoil saturated water content. So the first four layers you can collect it from VAPL using the notebook from module 1. That's the refresher exercise that you've done. After you collected all the data, you can create your own NetCDF file for your own basin. For this course, for this exercise, we will provide you with the created NetCDF file to save time, so you don't have to run this notebook data preparations. The exercise that you should look at is day 2 exercise NetCDF files. So with the day 2 exercise, I provide you with the NetCDF files that I've created for Upper Litani Basin, so you don't have to create it. So it can be filed in the data folder NC input. So we have ET monthly, land cover classification yearly. Yeah, as you can see here. So these are where you can find the files. You can also open this in QGIS if you want to see how it looks. For this exercise, we will use Python to read the files and to analyze it. So again, similar to day 1 exercise, you will have an exercise notebooks where you have to complete some tasks and answer questions. So if you follow through this notebook, you will find step by step how to first we need to import this, and if some package is not installed, you will see like module not found error. In this case, you can use this command and just copy it in a new code cell. Then you can install it. So I remember I think someone have access. Some have questions about a shapefile is not installed or something like that. So in this case, you can use this command to install it. And then you can just follow the steps, just run the code, import this, and here is to read the file. So in each step, there will be a questions. So the question is in the text cell, and you can also edit this if you open it in Anaconda Jupyter Notebook. So here as an instruction, you can just double click to edit the text. So in order to answer this question, you can start running this code cell so you can see the output. So here you can see all the attributes and metadata of the netcdf file that we prepare. And then you can answer the questions of what you see in this output. So there are in total 6 questions. The first 5 questions you can just answer by just running what I have already prepared for you. Just look at the output and answer what you see. The last question, you will need to write some small code of your own. You can create as many code cells as you want by clicking this plus button. So basically, the last exercise, you will analyze a different netcdf file based on the example that I give on the precipitation netcdf file. So maybe this will be a bit challenging for some of you who have not finished Python course or who have never done anything related to Python. So if you have difficulty, you can come to the afternoon live session. I will be there and you can ask questions and I can help you with running the script. But for the questions, you will have to answer it yourself. So there, in total 6 questions. After you type in your answer, so for example, you can just type in your answer here. And then you can press Control Enter to stop editing. So, and then you can save the notebook. Once you finish all the questions, you finish the task and answer, you can upload this to the platform. So in the exercise link, you will find the Add Submission button. So again, you will just need to upload this notebook after you complete all the questions and the task, and then save and submit it. And this exercise will contribute to 10% of the final grade. It's not mandatory. If you're too busy, you can do it later, but it will you will not be able to submit it before the deadline. So this will prepare. This will give you an idea how you can use Python to read the netcdf file, and this will be important for the next day when we run the model and get the output in netcdf format.